Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we'll be looking at GCSE Physics electric fields. Now, so we will cover today what electric field is and basically how it works, what are the main rules governing it, and maybe we'll cover some examples of what are the good examples of electric fields in daily life, etc. So, without further ado, let's get started. Okay, so now the important thing to consider is that any object that has a charge, static or not, any object that has a charge emits electric field. It has its own electric field. And the important thing to consider is that positively charged object will have electric field lines going out of it, and the negatively charged object will have electric field lines going into it. Like we can see here, a positively charged sphere has electric field lines going out, negatively charged one has electric field lines going in. Now, those lines essentially represent electric field because electric field forms these lines, and they are very important for understanding how electric fields work. Now, here, if we have a straight surface, electric field lines always, whether straight or not, but it's best shown in a straight surface, electric field lines will always go out of or go into the object at 90 degrees to the object itself. So, I mean, obviously here I just did a rough drawing, but here we can see that every time it goes out, it starts with 90 degrees towards the surface, but then it can bend, but as far as we're concerned, it always starts with 90 degrees to the surface. So if you get a question to draw electric field lines and you have a straight surface, this is essentially what you gotta do. Now, what happens if we have two objects together forming these electric field lines? Now, as we covered a bit in a previous video, opposite charges attract. So when we have two objects like so, one positively charged, one negatively charged, the electric field lines will leave the positively charged object as we already discussed. And then, guys, they will go to the negatively charged object. And they will form something like this, where this one will go straight to the negatively charged object, this one goes a bit out, so then it needs to bend, and then bend back to get to the negatively charged object, and so on, as you can see. And objects can together form these, change the shape of these electric field lines, rather than they going out like this forever. The electric field can be altered and impacted upon by another object. So that's what electric field lines are, and that's the sort of the main rules to draw them and to think about them. Now, we need to explain how is attraction between two objects of opposite charge. How can we explain that with electric field lines? Because this is one major point. These field lines allow us to understand some of these concepts that we already covered. Now, as you can see here, opposite charge objects attract. And we know that. You can do an experiment at school, no problem. We all know that. Now, but how do we explain this using the newly learned electric field lines? Well, as we can see, if we have two objects, initially their electric field lines will collide, because we have a positively charged object here with electric field lines going outwards, and we have a negatively charged object with field lines going inwards to the object. But at these points here, the field will collide. The electric fields will collide. And that's where this attraction begins. And because these are opposite charges, these objects start exerting force on each other, collision of electric field lines is required for these objects to start exerting force on each other, and because they are opposite charges, these forces happen to pull these objects in together. So that's how we can explain this. Now, another thing we can explain here is that when the lines are closer together, the electric field is stronger than if the lines are further apart. Right? So using that, we can explain why the bigger the distance between the objects, the less of a attraction they exert upon each other. Now, if you think about it, these two guys are pretty close. So they have 3 electric field lines colliding with each other. And that sort of determines the strength of the force, the strength of the electric fields. 3 lines collide. Now imagine if these guys were much further apart from each other. Then maybe only one line would collide, and therefore the attraction would be weaker. So we can use this concept of electric field lines not only to explain how objects of opposite charge attract each other, but we can also explain the whole idea that if we have objects further away from each other, the attraction will be weaker. And if we have the same objects of the same charge, same opposite charge, close to each other, then they will attract each other more. Because more lines get crossed. And that again sort of comes from the idea that the closer the lines are together, the stronger the electric field is, guys. So that's sorted. And one more thing we need to explain are sparks. How sparks come about, what's happening. I mean, so sparks essentially are often electrons jumping across, as we explained in a previous video. And then essentially they can carry current. The spark is a way to complete the current by jumping across a gas. That's essentially what's happening. So, how can we explain sparks with electric field lines? Now, imagine a charged object with a very, very high charge on it. And that object exerts electric field. It has its electric field. And because that electric field is so strong, because of the very high charge of the object, then what happens is that the air gets ionized. It either has electrons added to it or electrons taken away from it, depending on the charge of the object. And that ionized air normally is an insulator, but once it becomes ionized, well, it has charge, and it is also mobile. Therefore, air suddenly is able to conduct electricity, only when that electric field ionizes it. So basically we have a charged object, here we have Earth, and the air becomes ionized, and that makes it conduct electricity. And then the air conducts electricity to the Earth from that charged object to release that charge. And that's essentially what we see. That's a spark. That ionized air transporting completing the circuit and conducting electricity. That's what spark essentially is. And because of inefficiencies and things as such, it gives out light and heat. But at the core of it, that's essentially what spark is. And as you could probably guess here, that is exactly what happens when we have clouds above the Earth, and then when we have thunder and lightning. That's exactly what's happening. We have static electricity build up in the clouds, i.e. the charged object. Basically, clouds become charged, and then that charge is released to the Earth because clouds start emitting electric field and ionizing air, and because the charge is very high and we have ionized air, this allows the spark to jump from cloud to Earth. Basically, lightning is a one huge spark. So, this is it on electric field, guys. Thank you very much for watching. I really appreciate when you guys watch my videos. This is what I do. I hope this video helped you. If you think this video helped you, give me a big thumbs up. And again, I'll remind you, I do daily math, science, and some biomedical science videos. So if you want to stay up to date, don't be afraid to hit that subscribe button below. Thank you again for watching, guys, and see you next time.